Very good morning. Today we are going to discuss about upgrading of RAM in computer. How to upgrade, what are the requirements to upgrade, the procedure, step-by-step procedure to upgrade the RAM inside the computer we are going to see. In the last class we have seen RAM, different types of RAMs and differences among the RAMs, SD RAM, DDR1 RAM, DDR2, DDR3, DDR4 and also ROM bus inland random access memory. So we have seen the differences among these RAMs. So today we are going to see how to upgrade the capacity of system, RAM capacity, how to upgrade the RAM capacity system by adding additional RAMs in the system. This is our class today. So explain the procedure to upgrade RAM capacity of the system by adding additional RAMs under the topic of mass storage devices. So just once recall our RAM. Random access memory is a type of data storage used in computers that is generally located on the motherboard. This type of memory is volatile and all information that was stored in RAM is lost when the computer is turned off. This is a brief about RAM. So RAM is most important component in the RAM motherboard, which helps in processing the data, stores the data first in it, and whenever required by the CPU, it sends the information to the CPU. CPU reads the information from the RAM for processing. Again, results also stored on the RAM. So there is a important, RAM is very important part inside the computer which is installed on the motherboard. So if you have purchased a system with a certain amount of RAM, so if that particular RAM which we have got through the system, if it is enough to do our processings, okay. If the installed RAM is not enough to process our programs, if it's not up to the date to process our required programs, we need to replace the old RAM with new one. That is upgradation. So that we are going to see now. Upgrading RAM. Random access memory is a memory that the computer uses to store that data that is currently in use. Generally speaking, having more RAM can allow the computer to perform more tasks at once, though this is also dependent on variety of other factors. But if we have more RAM on the motherboard inside the computer case, there must be certainly improvement in the processing of the computer, improvement to the perform the task, more tasks at once. So if we have more RAM, if we have more RAM inside the computer, automatically we increase the speed of the computer. That is the speciality of the RAM. So if we have less RAM, already installed RAM is very less or somewhat less when compared to our need, the present need, we have to upgrade the RAM. So upgrading or replacing the RAM is one of the easiest upgrades we can make on the desktop or laptop computer. Upgradation is most important thing now, present days. Generally, the RAM is coming in the form of 2 GB RAM, 4 GB RAM, 8 GB RAM, 16 GB RAM, 32 GB RAM. Like that, the RAMs are coming with the desktop computers and also laptop computers. So earlier, first ever RAM was 640 kilobytes, which was in DIP packages. Those DIP packages, the DIP chips, integrated chips were directly soldering on the motherboard itself. So now we are getting the RAM in the form of sticks, RAM sticks or RAM modules with the capacity of 2 GB RAM, 4 GB RAM, 8 GB RAM, 32 GB RAM, like that. So nowadays, all the motherboards are providing, there is a provision in all motherboards where we can install our RAM or remove the RAM, or we can install or upgrade the RAM. In older motherboards, there was no such facility to upgrade the RAM. So RAM itself coming along with the motherboard in older days. But nowadays, motherboard is coming separate and RAM is coming separately. So whatever the RAM amount we want, we can install on the motherboard itself. We can upgrade or we can install. So this is upgrading the RAM. Adding memory to the desktop computer, that is nothing but RAM to the desktop computer or laptop computer, can instantly make the computer faster, increase system responsiveness, and make multitasking seamless. Adding more memory to the desktop computer, laptop computer, increase the speed and system responsiveness and also multitasking seamless. So these are the advantages in upgrading the RAM. So what are the steps? Sequence of steps for upgrading RAM. Now we will see the steps of the steps for upgrading the RAM. So before installing or upgrading the new RAM on already in the computer system, first we have to check how much RAM our computer currently has installed. We have to check whether how much RAM is already installed in our computer. Before determining how much RAM we should purchase, it will be helpful to know how much RAM already have installed in the computer. So without knowing how much RAM already installed in our computer, how can we purchase a new RAM? So that is why we must know how much RAM already installed in our computer. So we have to check first how much RAM installed in our computer. So to check how much RAM we have currently on our system, first click on the start menu or Windows button, right click on my computer or this PC icon on desktop, select the properties. We will see the installed memory. Installed memory is listed. So by seeing the installed memory, we can know how much memory is already installed in our computer. So this is a typical screen we get when we press system security and system. In this, when you press right click on the my computer icon or this PC icon, this window will be displayed. This contains the system information. This having operating system of Windows Edition, Windows 10 Home Singular Language, and processor is Intel Core i5, and installed memory is 8 GB. 8 GB RAM is installed on this system. So we conclude that our RAM is, our system's RAM is this much, and this is 64-bit operating system and x64 based processor. This also we have to note while making upgradation of RAM on this system. So this is the typical RAM. We can see screen which displays the RAM, how much RAM is installed in the system. Check how much RAM the computer and operating system can support. Just now in this screen we have seen this 8 GB RAM is already installed in this system. Now we have to check how much RAM the computer and operating system can support. Apart from the 8 GB, which is already installed on this system, we have to check how much RAM the computer and operating system can support. So without checking this, if you purchase more RAM, if that computer which is going to be upgradation of RAM may not support. That is why we have to check whether we have to check how much RAM it can support. So check how much RAM that computer and operating system can support. There are several factors that will dictate how much RAM your system can support, including the operating system and motherboard limits. So the several factors will dictate how much RAM the system can support. So this includes operating system and also motherboard limits. If we are using Windows, a 32-bit version can support up to 4 GB RAM, while a 64-bit version can support up to 128 GB RAM. This is the distinction between this 32-bit version and also 64-bit version. We will need to check the documentation for motherboard or run online system scanner to see how much memory the motherboard supports. If you have the documentation along with the motherboard, there is no problem. We can check the documentation. for how much RAM can that particular motherboard support. So that we can easily know how much RAM can supported by the motherboard. So check what RAM format the motherboard supports again. Just now we have seen how much RAM can support that motherboard. Here, check what RAM format the motherboard supports. There are RAM has gone through several versions over the years. There are number of formats in the form of RAM. The standard these days is DDR4 RAM, then double data rate RAM, DDR4 version. But if we are upgrading an older computer, you may need DDR3, DDR2, or even DDR1. So based on our system, motherboard supporting, we have to purchase the new RAM, that is nothing but RAM format. We can determine what type the computer uses by referring to the documentation or running a tool like CPU-Z, a freeware utility that analyzes the system. So check what RAM format the motherboard supports. So we have to purchase that particular RAM format only, which supports the motherboard. So typically nowadays all the desktop computers which are having 64-bit systems, so it also supports DDR4 RAM. And also determine the clock speed of the system, clock speed of the motherboard, and everything of RAM. RAM comes in a variety of different speeds. The RAM which we are going to purchase must be synchronized with the motherboard clock. If there are multiple speeds installed, the entire system will clock down the lowest speed present. This can actually hurt the performance of computer even if we are adding RAM. Generally, if we are adding the more RAM means the computer has to perform faster. But the upgradation RAM which you are going to install is different speed, it is having different speed, then automatically slow down the system performance. The clock speed of RAM is measured in megahertz. Motherboards typically support range of clock speeds. If we use CPU-Z to check the motherboard clock speed, we will need to multiply the displayed megahertz value by 2, since CPU-Z does not display the memory multiplier. All installed RAM should be the same speed for the best performance. This is the most important concept. All installed RAM should be the same speed for the best performance. So after seeing the speed, clock speed, and also how much RAM that motherboard supports, now we are going to see purchase the RAM modules in pairs. In what way we have to purchase the RAM modules in pairs, not a single module. Nowadays, all the RAMs are coming in the form of modules, SIM or DIMM modules. Maximum they are coming in the DIMM modules, dual inline memory packages. Modules are also called memory sticks. Nearly all RAM should be installed in pairs. The total value of each module should be within the limits of the motherboard. This is most important. If the total value of the pairs exceeds the limits of the motherboard capacity and motherboard allowing RAM capacity, if it exceeds, there is no use. So we must see the RAM allowing of motherboards. For example, if we are installing 16 GB of RAM, we will need to install either 2 8 GB modules or 4 4 GB modules. If the motherboard has an 16 GB limit, it is likely won't support a single 16 GB memory module. RAM often comes packaged in pairs to make purchasing easier. Many computers will work with only one RAM module, but this is bad practice and will have worse performance. We must have our RAM in pairs. RAM modules in pairs. This is important factor while upgrading the RAM on the motherboard. So these are the typical RAM modules. There are 4 modules are there. This one is on the RAM stick, also called RAM sticks. These are called typical RAM modules. Here also we can see this is the typical RAM module. You can see here also typical RAM module. So now installing desktop RAM, nothing but upgrading the desktop RAM. What are the steps to upgrade the desktop RAM? We will see the next. First, we have to power down the computer. So in sequence of steps, we have seen how much RAM already installed in our system. And next we have seen how much RAM can support further our system. And we have purchased our required RAM based on the speed of the motherboard, clock speeds. We have to, when tallied RAMs only we have to purchase. So all we have procured. All the RAM, the required RAM we have procured. So next we have to install inside the computer. For that, first we have to power down the computer. What you have to do? Unplug the power cable first. If you need to move the computer to access it easier, remove all the cables from the back. Nothing but we have to, generally the computer, the RAM we have to install on motherboard. Motherboard is normally inside the computer case. So we have to unplug the power cable from the computer case. We have to remove the computer case to where easier to remove all the parts. Place the desktop on its side somewhere that gives easy access, generally on a table. So nowadays workbench are coming. Workbenches are available in the market. We have to purchase generally workbenches where we can put our desktop on the workbench. Lay down the ports on the back closest to the table. So this is a opened computer case where we put on the desktop, on the table, nothing but workbench. So these are inside the computer case. So open the computer case. Some cases have thumb screws for easy opening, while older cases typically require a Phillips head screwdriver to open the computer case. Slide the panel off or pull it open after removing the screws. Make sure to remove the panel that allows access to the motherboard. The most important, we have to access the motherboard. For that, we have to remove that panel. We can determine which panel to remove by looking for the I/O ports on the back of the computer. These ports include monitor, Ethernet, speaker, USB, and more. They are connected to the motherboard, so remove the panel on the opposite side. We have to take care of while opening the computer case. So after opening, before opening the inside devices, before touching the inside devices inside the computer, we have to ground ourselves, because the human being have static electricity in the human body. The static electricity which is having in the human body may damage when the human touches the computer parts into the computer case. To avoid this damage of electrostatic charge coming out of the human being, so what we have to do? Anytime we work inside a computer, there is a risk emitting an electrostatic discharge that could damage the computer components. So electrostatic discharge comes out from the human being, and that could damage the computer components. So we can reduce this risk by wearing an anti-static wrist strap or by grounding ourselves before working on the computer. Touching a metal water tap will also ground us. The most important thing, we have to ground ourselves by wearing an anti-static wrist strap. So there will be no electrostatic discharge from ourselves. So this is anti-static wrist strap. We have to wear this, and we have to ground ourselves while opening the computer case. So like this, we have to wear the anti-static wrist strap, and we have to ground ourselves. So there will be no problem with our electrostatic discharge to our computer components. So this is nothing but anti-static mat where we have to put our computer case, and we have to wear anti-static wrist wraps, and we have to ground that to the table, and then easily we can open the computer parts inside the computer case. So then there will be no damage to the computer parts inside the computer parts due to electrostatic discharge from the human being. Then the next step is removing existing RAM if necessary. If it is too slower, too low, less memory, we have to remove the existing RAM, or we can add our new RAM to the existing RAM. That is our requirement. Based on the requirement, we do it. If we are replacing RAM, pop out the old modules by pressing down on the latches on each end of the module. The RAM module should pop out of the slot, allowing to lift it directly out. This is a method to remove the RAM, existing RAM. So we have to pop out the RAM like this. This is a RAM slot on this. So we have to release these notches, then pop out the RAM. Now check how the RAM slots are laid out. So we have purchased the RAM module. This is RAM module. We are removing the existing one. So to install the new RAM, we have to see how the RAM slots are laid out. Many motherboards have 4 slots for RAM, but pairs are typically not installed directly next to each other. For example, the slot may be laid out as A1, P1, A2, B2, and we would install our first pair on A1 and B1. Refer to the motherboard documentation to ensure that we know which slots to use. If you don't have documentation handy, we can often tell which slots are pairs by looking at the coloring. They may be labeled on the edge, which each label etched onto the motherboard. These labels may be small, so we may have to look closely. So before inserting the new RAM, we have to check how the RAM slots are laid down. These are paired with A1, B1 and A2, B2. So we install pair carefully. So we would install our first pair on A1, B1 and second pair on A2 and B2 like that. So these are the RAM slots on the motherboard, 1, 2, 3 and 4. 4 slots are there. We have to see which is A1 and which is B1 and which is A2 and which is B2. So based on that, we have to insert our RAM modules or RAM sticks here. Here also we can see RAM slots 1, 2, 3, 4. 3 are in white color, 1 is in black color. Here it is DIM1, DIM2, DIM3 and DIM4. So these RAMs are allowing DIM RAM memory modules, dual inline memory modules, indicated as DIM1, DIM2, DIM3 and DIM4. So based on this arrangement, we have to install our RAM on these RAM slots. So now we install the new RAM. Push each module directly into the slot, ensuring that the notches at the bottom line up. Apply even pressure directly to the top of the module until it is inserted and the latches snap into place on each side. If this insertion is loose, if the latches are not snapped into the place on each side, our RAM won't work. So be careful while inserting the RAM, and also latches snap into the place on each side. Do not force the modules in or you may break them, because if you force more, the modules may break. Nearly all RAMs is installed in pairs. Some computers will have difficulty with a single RAM stick, and using only one stick will decrease the performance. So we must install the RAM pairs. So like this, we have to install and press on it so that these notches will be snapped in each side. Both the sides, these notches must be snapped. So this is the correct way to install the RAM. If this insertion is not in proper way, these notches will not snap, so that the RAM won't work. These sides must be snapped. So after installation, we can see this RAM is correctly fixed, inserted, and snapped both the ends. Now close up the computer. With the RAM installed, close up the computer and screw the case panel back into place. Plug all the cables back in. So like this, we have to close the back panel and everything, side panel and back panel, everything. We have to close all. Now boot up the system, turn on the computer and allow it to boot into the operating system. We may be prompted to continue due to our new RAM installation. Verify that RAM is recognized or not. Open the computer system information to verify that the RAM was properly installed and is being used. Double check that the amount is being displayed and correctly, because we have installed the new RAM. We have to check whether our installed upgraded new RAM is it displaying or not. Whether it is accepted this installed RAM or not, we have to check. Windows, open the system properties windows by pressing Win plus pass. Verify the installed RAM in the system section. If we receive an error message or hear a series of beeps, the system might not be recognizing the new memory modules. Now what we have to do? Remove and reinstall the modules. Push down hard and modules until the clips fold back up. So only step is remove all the things and reinstall the modules again. Again restart the computer. Again we have to check. So checking the RAM, click on the start menu, Windows button, right click on the computer on my computer. Select the properties. You will see the installed memory listed. It should match the amount you installed. Because before installation, we have checked what was the RAM installed in the computer. And after installation, again we are checking the RAM capacity. That must match that amount of extra RAM we have installed. If the installed RAM in this present checking not to the up to the mark what we have installed the RAM, what RAM we have installed in the computer, so the computer is not recognizing, we can conclude. So if you encounter problems after checking this helpful tips, please contact the crucial technical support. Still, we have installed properly, everything even taken care of. If the installed RAM is being displayed and working in properly, no problem. After thorough checkings and reinstallations, still the problem is coming or the system is not recognizing the installed upgraded RAM, we have to take the help from the technical support. So this is all about upgrading the RAM, how to install the new RAM, how to upgrade the RAM, the existing RAM or new upgradation of RAM. So in the next video, we will see the demonstration video how to upgrade the RAM, what we have seen now. Now we will see a demonstration video on how to upgrade a system, how to upgrade a RAM inside the system, or how to replace the RAM in the existing system. So this video demonstrates how to upgrade the RAM in our system. So upgradation of RAM in our new system or upgradation existing system. So we have to gather the materials first. Open the computer case, remove the old RAM, open the computer case, remove the old RAM, insert new RAM, close the computer case and power on. These are the steps required for upgradation of RAM in our computer. So we required a warning, we have to see a warning. Electrostatic discharge can damage sensitive electronic components. To avoid this, wear an ESD wristband. So before opening any computer components inside the computer case, we must wear electrostatic wristband to discharge ourselves. Generally, the human being have a static electricity with him. So to discharge that static electricity contains in human being may damage sensitive electronic components. That's why the person who want to touch the inside computer components must wear this electrostatic device wristband. So this is the wristband. Here you can see. So electrostatic discharge can damage sensitive electronic components. To avoid this, wear an ESD wristband. So this is the wristband, electrostatic wristband. We have to connect this to our computer case so that ourselves grounded. So electrostatic discharge will be there. When we avoid that electrostatic discharge from a human being. And handling the RAM, mishandling RAM may damage it. This handling is incorrect. This type of handling is correct. So we have to handle the RAM like this. So this is incorrect handling. So like this, we have to handle the RAM. So no need to touch, because if you handle wrong way, this will be damaged. This edge connector will be damaged. So gathering the materials, this is the workbench and the required RAM, screwdriver, and wrist band, and this is the computer case. So the computer case, this is one where we have to install, upgrade the electronic wrist band, electrostatic discharge, electricity, static electricity from human being. This is the RAM slantles, and this is the screwdriver. So we have to open the computer case. There are different types of computer cases available in the market. So based on our computer case, we have to carefully open the computer case. So because in the market there are number of computer cases available. In this particular, this is the computer case we are opening. So like this, we have to wear electrostatic band, electrostatic wrist, anti-static wrist, and here we are opening the computer case by unscrewing this, and here also unscrewing this screw. So we are opening the cover, and we have to ground ourselves by connecting this clip to this computer case, the electronic clip. Now how to remove the RAM. So any motherboard generally looks like this. So here are RAM slots, available RAM slots. Here this is the computer case we are opening. This is a power supply unit, and this is a video card, and this is a CPU and fan, and here we have RAM slots. And the motherboard on which we are going to remove the slots, RAM slots, is here. So CPU and that fan on it is the RAM slots, and this is the RAM modules which are installed in the motherboard, and these are inserted in the clips. The both ends there are clips flipped in. Now these are properly inserted like this. So to remove this, we have to open the clips both sides. We have to open the clips, and this RAM will be freed. Then we pop out this RAM from the clips. So we have to handle this RAM. They like this carefully. So we are putting aside. We are removing another RAM by opening the clips, and we are inserting the new RAM on the motherboard. So these are flipped out. These clips are flipped out. We have to properly install the RAM wherever we want. So we have to check in which slot we have to install the RAM. So based on the notch on the RAM module, we have to insert, and we have to check the notch. This notch on the RAM slot on the motherboard and notch on the RAM module must match, and these are the new RAMs, and we have to remove carefully from the packet, and this is a single RAM. We have to put aside, avoid the electrostatic discharge, and we have to check the notch. This notch must properly match on the motherboard, and we have to insert the RAM on the RAM module on the clips, open clips, and we have to gently insert the RAM on that slot. When you insert gently on the slot, the clips automatically flipped in properly, and this clip must be adjusted in this RAM, must be perfectly contacted to the RAM snatch. The second RAM also we have to insert in the same way, gently insert, the clips automatically closed and fully contact with the RAM notches. So this is properly insertion of RAM and the RAM slots. So we have to close the case now. We have to close the case and we have to cover the computer case now. We have installed the RAM properly. So like this, we have to close the cover. Always we have to wear electrostatic wrist wrap when we have to screw up again. So after this, we have to power on the system, main power on. So system starting Windows and booting up. So we can start working like this. We have to power on the switch. Our system is starting. This is our method of starting innovations. So this is upgradation of RAM. This is upgradation RAM. In the next one, we will also see the overall RAM, overall computer memory in the next video, so that we can conclude with the RAM. In the next video, we are going to see overall memory inside the computer.
One of the most important components inside of your computer is the memory. We often refer to this as RAM. That stands for Random Access Memory. And that really is the most common type of memory inside of our computers. When we talk about how much memory is inside of your computer and should you be getting a memory upgrade, we're often talking about random access memory as the memory type that we are changing. This is not referring to the storage device that you have in your computer. You probably have a hard drive, or even these days SSD, which is a type of memory, but it's designed to store data over a very long period of time. And when we talk about how much memory is inside of your computer, we're talking about the RAM. We're not talking about the permanent storage space that might be inside of your computer. The reason that this RAM is so important is that inside of your computer, nothing happens unless you are executing a program that exists in this random access memory. So all of these applications and programs that you're using will only work if you've moved them off of your storage device, placed them into random access memory so that you can then use a spreadsheet, do some word processing, or surf the internet. Another type of memory inside of your computer is a very specialized type of memory called a ROM. That stands for read-only memory. These are memory chips that are inside of your computer that are not going to ever change. As the name implies, with read-only, we are only going to be able to read the information from this memory. We are not going to be able to change the information inside of this memory. So this is a great place for the BIOS that's used to start your computer. That way nothing can ever delete the BIOS. It's always going to be in this read-only memory. There are different kinds of read-only memory. One kind is a PROM, that stands for programmable read-only memory. This is where an engineer might write code to a chip one time and place that chip inside of your computer. So it is a read-only memory that is initially programmable. We also have an EEPROM. This allows us to take that programmability of the read-only memory and erase everything and write over it. So we're able to pull that chip out of the computer, put it into another device where we can effectively reprogram it and then put it back into your computer again. Obviously, these would be used for very unique purposes. We don't often use these EEPROMs inside of our computers because we're not often pulling the ROM out and making changes to it. One type that is inside of our computer, though, is an EEPROM. That stands for electrically erasable programmable read-only memory. So if you have flash memory, if you're using an SSD inside of your computer, if your BIOS is one that you can upgrade with a software program, it's probably writing it to EEPROM, which allows us at any time to electronically erase it and write anything else into that read-only memory. There's a very specialized kind of RAM inside of your computer called a static RAM. You may see this abbreviated as SRAM. This is very fast memory. It's used for some very specific purposes inside of your computer. Because it is so fast, it's also much more expensive than the traditional random access memory that we would use on the memory sticks inside of our computer. It's also relatively large when you compare it to that other type of random access memory. So it takes up a lot of room, a lot of real estate inside of your computer relative to the other memory types. Because this is so fast, though, we often will see it used on the CPU itself or just off the CPU as processor caches. You may see this referred to as level 1, level 2, or level 3 caches, abbreviated as L1, L2, and L3. The static, when we're looking at the memory requirements for an operating system or describing how much memory we have inside of our computer, we're really talking about the dynamic random access memory that's inside of our computer. This memory is called dynamic because we are always refreshing the contents of this memory. So there's always a refresh process that goes through this memory constantly so that it doesn't lose any of the information. That's different than the static RAM we were just talking about that didn't require the constant refresh. With our dynamic RAM, we'll always be refreshing and updating the information inside of that memory. This is also random access memory, which means we can put information anywhere on these memory chips and instantly access that information just by referencing a particular memory address. It makes it very quick to retrieve and put information into the memory. It's very different than if you were using a backup tape drive with magnetic tape, where you have to fast forward or rewind through the tape to find exactly the place where that information is stored. Because this is randomly accessed, we can simply ask for a particular address and instantly grab the information that's stored in that memory. We talked earlier about the dynamic random access memory. This is synchronous dynamic random access memory, and it's called synchronous because it is synchronized to a common system clock. You can think of this computer constantly ticking off the seconds, and every second there's a particular process that's occurring. Obviously, inside of our computers, there are many millions of processes that are occurring every second, but because it is synchronized to a clock, all of the other components inside of the computer know exactly what's going to be happening with the next tick of that clock as it goes by. We used to have the dynamic random access memory that was not synchronous, which means that there was no clock signal. The memory was simply accessed whenever the system would have availability. With this SDRAM, we need to make sure that we don't confuse that term for the SRAM that we were looking at earlier, which is the static RAM. So whenever we're putting more memory inside of our computer with an extra memory module, we're always going to be referring to an SDRAM module. Let's visually look at this single data rate and how it is synchronized with the clock that's inside of our computer. Let's look first at the clock signal itself. You can see there's an upper and lower as the clock is rising and falling on each individual clock cycle inside of your computer. So we have 1 clock cycle, 2, 3, 4, 5, and 6 total clock cycles on this particular diagram. And you can see with each clock cycle, we're able to transfer one piece of data. So if the first clock cycle is the first data, the second clock cycle, then we've got data number 2, the third clock cycle, data number 3, and so on. That's one significant characteristic of the single data rate is for every single clock cycle, there is a single piece of data. The type of memory that you'll find in today's computers is DDR memory. This stands for double data rate. As the name implies, it is twice as fast as the single data rate memory was. That's because we're able to both send data on the rising and the falling of the clock. So effectively, we can send twice as much information in exactly the same clock time. So we didn't have to change the clock speed of the memory. We simply changed how we were sending the information during that same clock period. If you were to look at a DDR module, you'll see that it has about 184 pins on the memory module itself. In the industry, there's an interesting naming convention to memory. We can describe memory as the total number of transfers that it can do in a single second, but we might also describe the memory as the total throughput available for the memory. If we're talking about a memory module and the total amount of transfers that it can do in a single second, then you'll see it described as DDR- the number. So DDR200 means that this memory can do 200 million transfers in a single second. To be able to describe this memory as total throughput, we simply multiply that DDR number 200 by the number 8, and we get a total of 1600, and we put the term PC in front of it to describe the total throughput. So a DDR200 has exactly the same throughput as a PC 1600. We're just describing this throughput in two different ways. If we were to put a single data rate memory and the double data rate memory side by side, you would see what those differences are in the total amount of information that was transferred. As you recall, with the SDR, we had a single clock cycle and we were able to send one piece of data. But with DDR, you've got double data rate. You can have a single clock cycle, but you're sending data on the high end of the clock and the low end of the clock, which effectively is doubling the amount of throughput over an SDR. If we were to drill down into the statistics associated with DDR memory, you can see the memory clock speed is here. That's referring to how fast the clock is inside of the memory itself. You've got the I/O bus clock speed. That's how fast the bus is outside of the memory, whatever the memory is connecting to. You also have the DDR speed. We mentioned earlier the DDR200. That's describing how many transfers you can do in a single second. I've broken that out as a separate column just so you're clear that a DDR200 is 200 million transfers in a second. And of course, if we multiply that times 8, we'll get the total transfer rate in megabytes per second. So a DDR200 multiplied by 8 gives us 1600, which means the module name is called PC1600. We can do a similar thing if the memory clock speed is 200. That means the I/O bus clock speed for DDR memory is also 200. But again, it's going twice as fast as the clock rate, which means we have a total of 400 million transfers per second. So we call this DDR400. Multiply that times 8, you get 3200, which means that our module name is going to be PC3200. So that's a very easy way to change the module name back to DDR speed, is to simply multiply by 8 to get the module name or divide by 8 to get the DDR speed. DDR memory was certainly an improvement over SDR because we were able to get twice the throughput of SDR, but we needed to go faster. Our faster processors and faster computers required much more throughput, so we came up with the next generation of DDR memory called DDR2, or Double Data Rate 2. This is twice as fast as the DDR memory that was previous. You find these memory modules are 240-pin memory modules as well. These newer DDR2 modules were not backwards compatible with the older DDR motherboards, so you couldn't grab your DDR2 module and put it into an older motherboard that was expecting a DDR memory module. You have to make sure that you're using exactly the right kind of module for your motherboard. Because of the architecture of DDR2, we're able to transfer twice as much information without changing the clock speed of the memory module. So a memory module that's 100 megahertz with DDR2 would need an I/O bus clock speed of 200 megahertz because it was transferring twice as much information over that bus. And of course, since it's double data rate memory, it would be twice that amount, or DDR2 400. And you can see DDR2 specifies that we're talking about DDR2 memory. That's 400 million transfers per second. And if we use our equation to multiply that by 8 to get the transfer rate, that means that we would be transferring 3,200 megabytes per second. And because this is DDR2 memory, we refer to it with the name PC2-3200 rather than the PC term that we would use with DDR memory. So if you ever see a number that's next to the PC or the number that's next to DDR, you'll know that you're dealing with regular DDR memory or with DDR2. The next generation of DDR is called DDR3. This is an improvement over DDR2. In fact, this goes twice as fast as DDR2 memory while maintaining the same clock rate inside of the memory chips. We're also able to get much larger memory capacities out of DDR3, and this also has 240 pins, which is exactly the same as what we saw with the DDR2. As with the previous memory types, this DDR3 memory is not backwards compatible. If you have a motherboard that is expecting DDR2 memory, you cannot put DDR3 memory modules. It simply physically won't fit in the computer, but even if it did, these two memory module types work completely different and they would not be compatible. With the DDR3, everything is now moving twice as fast as DDR2. So we might still have the same 100 megahertz memory clock speed, but now the I/O bus is needing to be 400 megahertz because we have now doubled that over DDR2. And of course, since it's DDR, we are now transferring 800 million transfers per second using that 100 megahertz memory clock speed. And we describe this as DDR3 800. Again, we multiply by 8 and we get the total transfer rate in megabytes per second. So for DDR3 800, multiplied by 8 gets us a module name of PC3 6400. So let's now look at DDR, DDR2, and DDR3 right next to each other. You can see the DDR, DDR2, and DDR3 examples I'm using here are all using the same memory clock speed of 100 megahertz. But notice that the I/O bus clock speed is identical with DDR. It's doubled for DDR2 and then doubled again for DDR3. So our 100 megahertz clock speed has a DDR speed of DDR 200, DDR2 400, and DDR3 800. And of course, with each of these numbers, we multiply by 8 to get the transfer rate that we use for the module name. And of course, remember that our module names are numbered. So with the DDR memory, it's a PC 1600. With DDR2 memory, it's a PC2 for DDR2. 3200, and then for DDR3, it's described as PC3 6400. I mentioned earlier that these DDR types were not backwards compatible, and not only do they work differently inside of the memory itself, but the physical chips are designed to be different, and they're designed this way so that we can't make a mistake by putting the wrong memory module in a different slot. You can see there are notches in the memory module, and these notches are at a very certain spot. So DDR memory, you can see where the notch is. For DDR2, it's moved a little bit over. For DDR3, it's moved over even further. So you can find the memory modules that seem to be the same dimensions. They're the same length, they're the same width, but you'll find when you get to your motherboard, you may not be able to put it into the motherboard itself because there's a notch that's inside of there that won't allow the wrong memory type to be installed on the motherboard. And it works exactly the same if you have a laptop that's using SODIMMs. Same scenario, you have notches on the SODIMMs that are marked so that you're not able to put the wrong memory type into a different memory slot.